Nachmittagsrunde.
Welcome to our first talk in the afternoon slot. This is Sebian. He's a researcher at the University of Rostock, and he'll be talking about IT security in network buildings, what's left to rescue when building lacks the basic concepts of security, and he'll be speaking about the weaknesses of building automation on the standard KNX.
Genau.
Hi, great to see that you all made it here. I would like to give a talk about IT security in network building, to give some attention to the topic. I'll try to ensure that it's friendly to beginners. You shouldn't need a lot of advanced knowledge, but I hope that those who know things about network buildings will be able to find interesting things in this talk. We're going to have a look at how network buildings work based on the KNX field bus. Then I'll be speaking about the security issues of these concepts, and I won't stop there. I will also speak about what we can do if the situation is the way it is. And if there's time, I will also speak about tools that could be interesting for people who are interested in researching this further. So how do network buildings work? I'll be using the example of the KNX field bus because that's the infrastructure we're using in our research institute. What is a field bus anyway? It's a bus that's designed to connect sensors and actors via a variety of media. That could be a copper wire, it could be internet or power line or Ethernet. And you can, even if you look closely, see a wireless connection, and we could have a light switch or a switch for the blinds and use it to trigger various actors. And if there are several participants speaking on the same bus, then we have the challenge that we have to decide and control who can speak to whom at which point in time, and that's why we need a protocol. And the combination of this is what makes a field bus system. Why do we do that? It's got several advantages. The first is an increase in comfort. If you have a large public building, for example, a university building, you can press one switch in the evening and all the lights would turn off, so the electricity isn't on all night. You have more flexibility in rearranging rooms so that you can use a switch for different things. If it's easier to reconfigure because you have a network. It can also help reduce running costs. Of course, just running costs because the upfront costs for installation will be higher, but it allows to reduce costs for energy management, and it also decreases the amount of material you need. It doesn't matter for a building so much, but for instance, in a car, you can save a lot by saving a few kilos of wire. The downsides are that the entire thing is getting more complex and more expensive to install. There's a lack of security. There's a high potential for attacks. Why do I speak about KNX? It's not one small thing we have in our back room. It's the successor to the European installation bus. It's an open standard specified in 2002. It was normed and standardized both in Europe and internationally. And it's a vendor-independent consortium. And if somebody builds a device, they can get a KNX certificate and connect. That will allow them to connect several KNX devices in a network. You needed software for this, or you need to configure this, and that's what the engineering tool software is used for. Let's have a look at how KNX works. There is a physical address space that's divided into 3 parts. There's the area, which is 4 bits. These can be, for example, separate floors of a building, or perhaps even separate buildings. Then there are separate lines. These 2 might be used for 1 floor of a building. That is 4 bits as well. And then there are several devices. There are devices with an 8-bit address, and the number of the bit length determines how many devices and lines and areas you can have. And we have these devices that are connected through the connection medium. They are coupled via these LK couplers, and these again are coupled in an area. And there's this address, but there's also the logical address space. There are 2 ways of using this. There's a 2-step or 3-step address space, and for each project you have to decide upfront which you want to use, and you have either 2 or 3 groups that are separated by a slash. Now we can assign several devices to a group. For example, the one that's highlighted in orange here, that might be a light switch. It's in a group with a lot of other devices. Let's say all of them are lamps. So if this light switch wants to toggle all these lamps, it will send a program to the communication medium that will be forwarded by all the couplers to ensure that all the devices in this group receive the telegram, not program, sorry. It won't get much more technical than this. The package structure of this KNX, there are some steering flags. There's a source address, or some control flags, and there are source and destination addresses. They may either be physical or logical. And to determine which one it is, there's a separate bit for that. Then there's routing information. 6 hops will get you anywhere in the network. So if this is set to 7, then the packets will be discarded. Then a length specified how much data is in the payload, and a parity bit.
Wenn wir jetzt also ein bisschen rausgefunden haben, wie so vernetzte Gebäude funktionieren, dann schauen wir mal ein bisschen an, welche Sicherheitsprobleme da passieren.
Now we look at the security problems that turn up.
In der IT-Sicherheit, über die wir hier sprechen, oder ich spreche,
we're talking about IT security.
Schutzziele.
I'm talking about different goals, different requirements, protection goals, for example, confidentiality. Confidentiality is the property of a message that it's only intended for a limited circle of recipients. That's a definition from Wikipedia. For example, lights on is the message. The message is intended for the lamp.
Einfach an den Bus klemmt.
If somebody unrelated listens on the bus, then that other device shouldn't be able to read what's in the telegram, what's in the message. The protection goal, authenticity, is, well, the property of originality, accountability, and trust.
Wenn jetzt irgendjemand einen anderen Lichtschalter benutzt oder vielleicht sogar einen Lichtschalter dazu,
If somebody uses a different light switch or adds a light switch, it shouldn't work. The lamp shouldn't accept messages from a rogue light switch.
noch irgendwie Zubehör zu unserem KNX-System dazu
If
kaufen.
we add accessories for our KNX system, like a fingerprint sensor,
Okay, wenn ich da meinen Fingerabdruck drauf mache, um in die Garage
when I add my fingerprint to get into the garage, only I should get into the garage.
verifizieren können, dass der Absender der es sein soll. Wir haben also jetzt irgendwie ein bisschen über Sicherheit.
We have now talked about the different notions in security.
Wir haben
We have no encryption, so that we have no confidentiality, we have no authorization.
dass jeder auf diesem Bus
These are fundamental problems that everyone can talk and read on that bus.
irgendwann auf die Idee, vielleicht ist es ja ganz praktisch, da noch ein Gateway dazu zu
Now,
bauen.
it would be nice
Dann kann man
to have some kind of gateway
was warten und so weiter. Und dann ist man plötzlich
so
auch nicht
that you can do remote management
und
attached to the network.
Vernetzung, nicht nur eine Etage von dem Gebäude, sondern ein ganzes Gebäude.
Networking increases,
Dann
not just inside of buildings. You want to network multiple buildings,
das Schadenspotenzial für einen Angriff.
and all this increases the
Und
attack
jetzt haben wir auch noch
surface
Systeme, die sich
and the
maschinell
reach of
suchen lassen. Ich weiß nicht,
breaches.
wer solche Suchmaschinen, zum Beispiel Showdown, kennt. Dann
example,
findet man DDC-Controller, die in solchen Gebäuden
There are automated search machines,
Typ suchen, dann finden wir auch schnell welche, die irgendwie in Flughäfen.
search engines that can
Dann ist immer so,
automatically
okay, wenn ich die
hunt for vulnerabilities in such networks.
Leute, die gut genug sind,
The security people that are good enough
finden in solche Systeme hinein. Und dann haben wir noch eine andere Situation.
are going to get in.
Wenn man so ein Gebäude baut,
Or one example would be Shodan.
irgendwie
When a
Bedienelemente für die Nutzung
building
dieses
stands
Systems
there
funktionieren,
and everything works,
keiner auf die Idee, diese Gebäude jemals irgendwie für
The-
zu patchen. Die haben extrem lange Laufzeiten,
no one gets the idea to patch these buildings, their systems,
zumindest.
for security enhancements.
Okay, gerade bei den Gateways wollte ich nochmal sagen, wenn wir jetzt Gateways dazu bauen,
Concerning the gateways, if we add a gateway,
Systeme dazu, das Gateway ist irgendwie abgesichert, da würde ich gerne auf
the gateway has been secured.
den Vortrag von Thomas Roth vom 34C3 verweisen, der hat seinen Vortrag
There was a talk from Thomas Roth at
Das war so ein bisschen
34C3.
für mich, hier diesen Vortrag zu halten. Schaut euch das an, wenn euch das interessiert. Der hat Eindruck,
Watched that talk.
dass
He
die
showed
Gateways eigentlich Scheunentore sind.
that these gateways are wide open.
Zurück zu KNX. Welche Angriffsmöglichkeiten haben wir? Wir haben also
What kinds of
die Möglichkeit,
attacks are
alles
possible
mitzulesen, was da drauf
on
läuft.
KNX?
Eine Erweiterung KNX Secure benutzt, zu der ich dann gleich nochmal.
Unless you use the extension Xsecure,
Das passiert bei uns am Institut.
you can listen to any
Gebäude bekommen,
messages
da
on
war
that
der
bus.
Feldbus installiert. Mein Chef kam auf die Idee,
The field bus was installed. My boss had the idea to look at the light switch, and
kommt die Firma vorbei, die
logged
das Gebäude
was
installiert hat und sagt,
the message is running on that bus.
die Uni war ein bisschen sauer und wie das immer so ist mit
And the installing service company,
und dann braucht man viel
the
Gespräch,
service provider, was
dass man das Ganze irgendwie als
try to roll it off to liability.
de facto wurde dann der Zugriff auf den Bus im Gebäude untersagt.
De facto,
Daraus wurde die nächste Idee.
the administration forbade access to the bus.
Gucken mal, wann da über das Klingeldrähtchen ein bisschen Spannung läuft und kriegen daraus Nullen und Einsen. Wir kennen den Telegrammaufbau.
If we
das Protokoll.
simply measure the voltage on the bus, we get zeros and ones and can see what's going on the bus.
Man kann irgendwie ungezielt störend sprechen. Das ist irgendwie so die Kategorie Denial of Service. Das ist irgendwie immer
You can
im schlimmsten Fall
run denial of service attacks by simply doing anything on the bus, random stuff.
Aber
You can cut it.
nicht so spannend wie die Art und Weise zu sprechen, wo man
Which is so-
quasi eine Steuerung übernimmt, eine Fernsteuerung hat. Wenn ich plötzlich
Not very interesting.
Klimaanlage und so weiter von öffentlichen Gebäuden in großem Stil fernsteuern kann, dann kann ich vielleicht viel Unfug machen und wäre ich das neulich die
If I'm able to control
plötzlich komisch die Köpfe verdrehen,
air conditioning of large buildings, I can do a lot of damage.
im Hintergrund mal eben kurz den Beamer umgedreht, um zu signalisieren,
My boss, for example,
irgendwie überall gegenwärtig.
instructed the beamer to flip the image.
Was wir bisher so als Experiment hatten, war dann auch noch den Personenbezug zu zeigen.
But the most interesting part of the project was showing that these data are personal. On the left-hand side, you can see our institute's building. In the middle, there's a movement sensor where you want to, I mean, it makes sense. You want to ensure that there's always lights on in the corridor if you need them. But of course, they can also be used to track people. And if we carry on the idea of Daniel Kriesler at 33C3 mining Spiegel, then we can think about what kind of information we can get from this data. If we're creative, we have a floor plan of the building. It's an office building. These are individual employees' offices. There are auditoriums, and the thing on the top left, that's the bathrooms, and the things in red are the movement sensors. And our toilets have a small
wenn jemand auf der Toilette war und die Bewegungsmelder dort
room where the taps are, and
danach muss durch den Waschraum, in den Flur.
Each time somebody has visited the bathroom,
in dem Waschraum aufgehalten hat, dann hat
they have to go through the room where the taps are and the sinks are, and if they spend less than 3 seconds in that room, they likely didn't wash their hands. And if we then see which sensors they've passed on the way in the corridor, we can suddenly tell whose hands we no longer want to shake. Of course, this experiment wasn't very popular, and of course, your employer may not be interested in who didn't wash their hands, but it's still possible to gather this data, and we have to deal with that. And this, I hope, leads me to the most interesting part of the talk. The situation is the way it is. We have these buildings, we go in and out, and we can't really do anything about it. Of course, we can decide not to go to the lectures, but in case it's my employer we're talking about, then it's already more difficult to not show up. And of course, this technology exists in all kinds of public buildings. So what can we do about the situation? How can we react? A colleague of mine said, right, let's start by quantifying the risk by raising awareness for what is a problem and what might not be a problem. I mean, if I can trigger the light switches in the office next door, of course that's fun for 2 days, but it gets boring after that. And we thought we'd classify these attack vectors and check how much knowledge is necessary for them. Do you need special knowledge? Do you need simply basic knowledge? Or do you need no knowledge at all, like cutting a wire and suddenly the building is no longer able to be used? And the less knowledge you acquire, the more likely an attack is. And we can also look at where an attack can happen. Can it happen inside the building? Can it only happen in the vicinity of the building? Or can it maybe happen anywhere in the world? Then we should look at the potential damage. Is it perhaps negligible, or is it personal damage? Maybe even, is it financial damage? And how visible is the attack finally? If somebody's only reading, like for example in a power station, and your competition can read along on the bus system, that might be very valuable to them, but you may not immediately notice. And if you have buses where people communicate normally, it might get lost in normal traffic, but if you're doing a lot with new or unusual addresses, you might notice the attack. And that's simply to quantify the kinds of attacks that are possible and the potential for damage in order to make this more tangible instead of simply saying everything is terrible and you can be attacked at any time. The next thing my colleague did was to try and quantify it, to sum it up in a number. And he said, let's look at static and dynamic factors. If you have a device and install it, you can say device X that I'm adding to the network now. What kind of device is it? Is it a simple voltage supply that can't even speak on the bus? Because that's another thing that KNX can do. It sends voltage to devices, and for each line there may be a power source, and that might be less relevant than devices that can talk on their own. Next, how physically accessible is the device? Is it a light switch in the bathroom of a public building? Then anybody is able to access it. Or is it a device that's in a locked area of the building, for example, a server room where only very few people have access? And then you can look at how physically accessible the bus medium is. Let's say we have an access control system that's linked to the bus system, then we definitely don't want to have the bus running along the exterior wall, because that would make it a lot easier to access for attackers. And then we can look at how far we can reach, to how many other devices can we reach in this space. And that depends a bit on the way the network is built and whether or not it has filters. All this can be considered during installation. And if you bear this in mind during installation, you can create a heat map or an installation help that says if you add the device at this place in the network, you will increase risk by this or that amount. And this would take work off the shoulders of the people installing devices in this network, because they may not be able to think about these things at all times. Dynamic factors could be the number of telegrams that are running on the network at any point in time, and then what kind of telegrams those are. And this brings us neatly to the next idea. The bus itself has the basic concept of as few cables as possible and as many devices as possible. That's great. We have a few cables. We don't need to spend a lot of money. But the attack surface has increased a lot. If we don't have any filtering, then we can access anything from anywhere and talk to any devices and do silly things. In an automotive situation, we might quickly realize that it's a bad idea to connect the ABS and the entertainment system without any protection mechanisms, so we could create separate zones for them. One of them that contains the light system and another that connects the air conditioning. And now we can no longer use a light switch to make sure that no windows can be opened anymore, because we've sucked all the air out of the auditorium. Of course, that means we need more cables, but it also means more security. But if we have to be considerate in what we're doing. We can't do this blindly. One thing is filtering and package inspection. So we can use these couplers and check who is speaking to whom, and is that plausible? Is it a plausible context? Do we want to allow this message, or should we discard it? And in the top right here, you see the basic package structure of KNX Telegram. And we can prevent implausible forwardings, but it doesn't prevent spoofing, because we can use any source address that is looks plausible, and suddenly we've manipulated the context. And this only works across broadcasts. So when in doubt, we have to decrease the broadcast domains. And of course, we can
verwerfen wir können sagen,
we can, instead of saying we discard everything that's implausible, we can use a whitelist and say we'll only accept that which is plausible, and things we don't know we simply ignore. Because we have to do a kind of project definition in this KNX, because we know who's going to be part of this network. We know who is able to speak to whom, who is supposed to be able to speak to whom. We know what a message looks like, and we know logical places in the network, and then any filter mechanisms could swallow anything that's not on our whitelist. And it's got the same advantages and drawbacks as earlier. We're protecting against implausible forwardings, but it doesn't protect against spoofing, and it only works across broadcasts.
Nur in gewissen
and only in certain frameworks, because if your average sender sends an average message to an average recipient, then doesn't mean that we've narrowed down the message format successfully. If we continuously switch the heating on, off and on, then these might be normal telegrams that can still destroy the device. Another thing is net flow analysis and looking at the traffic happening in various areas of the networks, how many telegrams in how much time, with how much of a gap between them. And now we add an agent to each broadcast area. These tend to be called sensors, but I don't use that term because it means something different in the context of field buses. So these agents are what you can see in these blue and green areas, and you can always these always hear all the telegrams running over the bus, and then they can use the bus medium itself to send a statistic aggregation to a controller, and it has an overview of the network and can decide, for example, if it notices that a lot of unusual packages are running over the bus in a certain area, you could maybe attach it to a warning system and say if there's too much traffic, we trigger an alarm. This scales really, really well. We only need one collector and one agent per domain. We can use the existing communication infrastructure, so it's in-band. We can install it live, and it works robustly whenever a device might go out of service, as long as it's not an agent. But even if an agent fails, then the rest of the network can continue. And it allows us to use very little technical hardware while still surveilling a large part of the network. We're still not protected from people listening in, and we have the problem that a denial of service attack that causes a lot of traffic, we're increasing the problem because we too are causing traffic on the network. On the other hand, somebody else might already have access to the bus and might already be breezing along, and they would probably be interested in the security analysis information. This might be critical. We'd have to consider that. And in building automation, we have the problem that we need to distinguish rare occasions or rare messages and attacks. For example, if nobody ever turns on the lights in the broom closet, but we, because we spilled some coffee, need to access some cleaning supplies, then that might trigger a false alarm. And if we have too many false alarms, then people will no longer trust the alarms. If we use machine learning to distinguish between what's normal and abnormal, we must take into account the fact that usage of buildings can change. But if we do this, we open the door for some more complex attacks that gradually modify what counts as normal for a building. And another idea that we've been taking up, a colleague wants to look at what happens if we look at the voltage on these wires and see that notice that there's always been a certain length of the wire, and if this length suddenly changes and the voltage might change a bit too, you can see this in this graph. There's a 0 and a 1 on the bus, and if that suddenly changes, then that might be suspicious. We hope this protects against adding things to the network in between devices. We hope we might even be able to fingerprint devices in the same way that it's often done in RF devices. We're probably very vulnerable to electromagnetic interference, and it's probably a very difficult to and a solution that's very difficult to install, and that has to be adapted anytime something changes in the building, something is reconfigured. And part of this is why we're using these systems in the first place, because we want to have an ease of configurability.
We have all these nice ideas. We need test data. Who can provide us with test data from buses that have been attacked? And there's also the problem that this data is sensitive. For example, as a private person, you also want to protect your reputation. You're not keen on giving out this data usually. If I give data to someone, I don't know exactly what they are going to do with the data. But still, even if we don't have real test data, we need test data. So we tried ourselves to generate some test data. So please, we have these provide test data. We have made these public, or and if you want to, you can contribute. How did we do that? We logged all data in our building at a time where we were still allowed to do that. We asked everyone concerned and had them allow us to do that. Any data that points to attacks, we're going to look at that. The possible messages, we classify them. And we sort them by time. We have this original Telegram stream, this message stream. Oder in Kombination das Verändern von Telegram und we alter the stream, we manipulate it, remove some messages. Da können wir genauer hingucken und dann stellen wir fest, es gibt we add messages, modify them and remove some others. Da gibt's einen Wochentag. In an office building, you have a weekly rhythm. Samstag und Sonntag nicht so. At Saturday and Sunday, there are different patterns. In the morning, in the evening, at night, the patterns are different. You can see on the bus whether the weather is warm or cold. Messages that are always coming at the same time.
Benutzerinduziert, wie das, wovon ich gerade gesprochen
There are other messages that are triggered by the users of the building. You can see all kinds of stuff on this bus.
Okay, in dem
Okay,
künstlichen Test, also diese Art von Muster
in the artificial test,
jetzt
you have to
Angriffsszenarien simulieren wollen.
consider these
Was haben wir in unserem Test
properties, these patterns.
QR-Code folgt, finden werdet, für Angriffe integriert.
What are you going to find behind this QR code?
Der zählt, wie lange das Paket noch weitergeleitet wird, bevor es verworfen wird.
How long the packet is going to be transmitted
Wir haben
before it's dropped?
verschoben, auch mal eine Stunde zurück, um Timing-Angriffe.
We added timing attacks. We moved messages.
Wir haben Replay-Angriffe
We added some replay attacks. I mean, duplicated messages.
Leben an das Licht an und immer wenn ich auf dem Bus
Colleague switches on the light,
direkt danach ein Telegramm, was genau dieselbe Lampe wieder
and right after that, I send another message that switches the light back on, back off. That's a denial of service attack.
keine Ahnung haben, warum nicht.
And the colleague is not going to have any idea why the light switch doesn't work.
Das soll jetzt gar nichts heißen, irgendwie hier.
That's not going to mean that those who built field buses
Schwierig, Sicherheit jetzt auch.
didn't do a good thing. It's quite difficult to retrofit security in a bus system like that. There are a lot of problems. Why is it difficult to
Wie viel Geld sind wir bereit in die Hand zu nehmen,
retrofit
damit
security?
der Kollege mir nicht nebenan den Licht ausschalten kann? Wir haben eine Komplexitätssteigerung von solchen
We
Systemen.
have an increase in complexity in systems of this type.
Wir haben gut dokumentierte Schaltschränke, die
We have somewhat well documented
naja, da hat man jemand,
wiring cabinets,
wollte es gleich noch dokumentieren, ist dann krank geworden und so weiter.
but sometimes people become ill.
Erosion und der Status, wie das Gebäude
The guy who wrote the documentation became ill.
also als potenziell.
No one has a 100% complete
All
documentation.
diese Geräte irgendwie Schlüsselmaterial hätten,
If all these devices even had key material, you would have to distribute the key material,
Schwachsinn, dass hier irgendwie
you would have to manage the keys.
müssen wir die größer machen, mehr Ressourcen dazu packen. So ein
You have to make them more powerful, the devices, so that they are more capable of stronger encryption.
Problem. Man
We
kann
have the issue of personal data,
den Adressraum noch vergessen. Die Adressen sind so klein, selbst wenn es verschlüsselt wäre, wir können es einfach
of data that can be associated to persons.
Adressen haben. Und bei der Klassifikation haben wir das Problem, was ist normal in einem Umfeld, wo sich die Normalität vielleicht die ganze Zeit ändert.
We have the issue that you don't know exactly what kind of message patterns are normal. These patterns, the patterns that are normal change.
Dann kann ein Angreifer einfach schleichende Veränderungen machen.
Attacks could also try to replicate this gradual
Nicht jeder ist IT
change of patterns.
und wenn wir solche
Not everyone is an IT expert.
ausschreiben, dann sollte meiner Meinung nach
In my opinion,
die Sicherheitsmerkmale in der Ausschreibung schon als Punkt
IT security should be part of the request for proposal.
Systeme als sicher verkaufen, diese auch entsprechend zu gestalten und wenn sie
If service providers sell systems like that,
in Form von Patching-Mechanismus, mir ist nicht bekannt, wie das funktionieren soll. Im KNX-System, ich habe das vorhin etwas ausgelassen, gibt es das
the proposals need to
Protokoll, wo dann verschlüsselt
need to ask for baked-in security.
gab's so gut wie keine solche Geräte. Wenn man jetzt also das Gebäude
These buses have been designed and older buildings were built. The
Nachrüstaktion
security technologies didn't exist in part.
einfach nicht. Genau, und dann kommt vielleicht die Frage auf, finden sich solche problematischen Situationen auch in anderen
Are there issues like that in other areas? For example, power stations, hospitals,
Forschung machen, kritische
manufacturing plants,
haben gedacht, wir fangen
ports,
an und holen uns jetzt Experten ins
ships,
Boot,
cars.
die draufschauen, bevor wir das System gebaut haben, damit Sachen richtig
We need to get
Ich glaube, ich habe noch
people on board
Ganz kurz noch ein bisschen
to have a look at the security issues.
Geräte kaufen ist teuer. Vielleicht kann man das nicht so super gut lesen. Das weiß ich nicht so genau. Im Zweifel schaut ihr auf Media CCC. Da könnt ihr die Links alle auch.
This may be a bit small, the font, so you can't read it exactly.
Da kann man sich selber.
There is KNX Virtual,
Die sehen dann zum Beispiel so aus.
where you can configure your own virtual devices.
Lampen und Dimmer.
The devices on the top right are lamps and dimmers.
Entsprechend mit der Engineering Tooling Software konfigurieren.
You can then configure these with engineering tooling software, engineering tool software, ETS.
Kann man auch einfach gucken, welche Telegramme über den Bus laufen.
You can use that software to watch messages on the bus.
Logischen Adressen mit.
You can look at the logical and physical addresses.
Das lässt dann
Next tool is NetNode.
Und zusammenklicken und dann auch losschicken. Das kriegt man auch kostenlos.
Which allows you to configure analysis.
Und all die anderen Tools sind Sachen, die
Let it run.
ich hier verlinkt habe. Bei den Gateways.
All these tools I have linked here on this slide.
Aufgefallen, nicht alle Gateways können.
Not all the gateways are able to
die irgendwie
process all messages.
an sie adressiert waren. Aber wenn man jetzt so ein Full Take, wenn man alles mitnehmen will, ist das
If you
vielleicht.
use a full take,
Inzwischen benutzen wir immer den
it may not work.
Stick Gateway von Weinzel und
For example, the Weinziel gateway.
meine ich, Entschuldigung. Und damit haben wir auch zum Beispiel die Agenten und Kollektoren von einem Netflow-Experiment gemacht.
We have also done experiments with NetFlow.
Danke sagen bei all meinen Kollegen, Thomas Mund, Johannes
Thank you to all my colleagues, Thomas Mond,
Maximilian
Johannes Golz, Johann Bauer, Andreas Soljastek, Maximilian Jung, Martin Peters, and other colleagues at the Lehrstuhl für Informations- und Kommunikationsdienste of University of Rostock.
Die kleinen Icons, die ihr im Vortrag gefunden habt, die durfte ich lizenzfrei hier verwenden. Wikipedia hat mir auch geholfen. Und zum Abschluss, worüber haben wir geredet? Wir haben gesagt, wie funktionieren vernetzte Gebäude? Wir haben herausgefunden, so
What did we talk about?
über Medien mit
How do network buildings work?
Wir haben uns angeguckt, wie so eine Adressierung bei
We had a look at the security issues.
Wir haben danach darüber
We
gesprochen,
have talked a bit about
es gibt de facto keine Verschlüsselung, wenn man nicht die Erweiterung
ways to solve these problems.
überall angekommen ist. Bei uns im Gebäude ist es zum Beispiel noch nicht der Fall. Wir haben keine Identitätsprüfung, wer da spricht. Eine
In
zunehmende
our building, we still have many of these issues that we talked about.
unfassbar lange Laufzeit.
We have no identity checking.
Bezug von Daten.
We
Und
still have personally associated data.
Situationen umgehen. Erstmal das Risiko darstellen, Bewusstsein schaffen, dann einfache Konzepte, Zonenkonzepte, Filterung. Dann haben wir über Netflow gesprochen, ein paar Geräte dazu tun, um über statistische Auswertung die Gesamtsituation ein bisschen zu
We
kontrollieren.
talked
Vielleicht ist sogar was möglich über
about
physikalische,
statistical analysis.
potenziell sogar der Gedanke, ob man rauskriegt, ob da jemand mitliest, um endlich auch diesen
We talked about the question whether it's possible to see if someone is listening
wir anfangen können, damit richtig zu experimentieren.
and about the
Damit
test
komme ich zu meinem
approach.
Ende und ich sehe gerade
I'm
nicht,
coming to an end.
Fragen haben, aber falls ja, dann sehr, sehr
I
gerne.
don't know if we have time for questions.
Vielen lieben Dank.
Thank you.
Dankeschön, Simeon.
Thank you, Simeon.
Wenn es Fragen gibt, wir haben 2 Mikrofonengel im Raum, stellt euch doch in die Gänge, dann können entsprechend die Fragen entgegengenommen werden.
If you have questions, please go to the microphones.
Wir scheinen auch keine im Internet zu haben aktuell.
Ansonsten könnt ihr ja auch jederzeit gerne noch an uns herantreten.
There seem to be no questions.
Da findet die Slides und dann
My address is there on the slides.
sind daran interessiert, falls jemand Assoziation Gedanken
If
hat.
you want to
Habe ich noch auf der Konferenz?
contact me, please do so.
Konferenz für Fragen.
Bis heute Abend, ja. Dann muss ich.
I'm going to be on the conference until tonight. One question.
Dass wir genau die Luft
Why do you think
gesehen haben. Habt ihr
that we didn't see the air gap?
verbreitete Sachen wie das Philips Hue Gedöns
Have
getestet?
you considered, did you test Philips Hue?
Wir haben auch andere Sachen ein bisschen angeguckt.
We looked at some other buses.
Mit dem ich mich noch am meisten selber mit beschäftigt habe.
KNX is what I've looked at personally the most.
Wenn dich das interessiert, dann würde ich vorschlagen, wir tauschen einfach Kontakt aus, dann vermittle ich dich.
If you're interested, let's exchange contact data.
Die kann dir mehr sagen als ich vermutlich.
And I'll show you some people who can tell you more about that system.
Vielen Dank dafür. Noch eine Frage bitte.
Thank you.
Wie funktioniert denn das mit dem KNX Secure hier drüben? Wie funktioniert denn das?
How does KNX Secure work?
Haben die Vor- und Nachteile dieser Lösungsansätze quasi abgewogen?
Ja,
How did they weigh the advantages and disadvantages? Well, you need new devices, not just the couplers. You really have to exchange the light switches. You have to exchange the lamps,
möchte ausgetauscht werden.
replace
Jetzt musst
the
du
lamps
jemanden
and
finden, den du
switches.
davon überzeugen kannst, dass in einem Gebäude, wo das Licht an und ausgeht, wie es soll.
If you can convince someone that in a building where everything works, lights can be switched on and off, that it's a good idea to actually replace everything. The next question comes up with how good is that crypto?
Und das größte Problem ist eigentlich die Verfügbarkeit.
How long is it going to last? And the biggest problem is
Das ist jetzt hier nicht das schwarze Schaf, das ist nur ein Beispiel.
what's the availability?
Dann guckst du natürlich, was ist der Stand, was machen andere Leute.
You have to look at what are others doing.
Die waren erst ziemlich sauer, als wir irgendwie gezeigt haben, dass es da Probleme gibt.
When we showed people that there are problems, they became angry.
Bei Kollegen von
People became angry, the owners,
sagen, das sind Probleme, die müssen wir angehen. Und
that there are problems and that we have to
Produkt kaufen kannst, weil es
take care of these problems.
Geräte gibt, die das schon
But the question is, can you actually buy solutions?
installieren und dann bist du in der Situation, in der wir jetzt sind.
So we are still in the situation where we are right now.
Vielen Dank für die Antworten.
Thank you.
Gebt ihm einen freundlichen Applaus dafür, dass er uns den schönen Vortrag hier gehalten hat. Bitte.
Your translators were Philo and
Walker.